Hello, in this video I'll be talking about three-dimensional figures and spatial reasoning. In the top of this page here I have a few two-dimensional figures. Here we have a circle, here we have a square, here we have a triangle. These figures are in two dimensions, so like this square has a length and a width, or a side and a side. The triangle has a base and a height. Whereas when you look down at these three-dimensional figures, this cube here has a side and a side, or a length and a width, but it also has a height. And this prism here has a length and a width and also a height. And again, here we have this cylinder. It has a circle on top, just like this circle, but then it also has this third dimension of height to go along with it. And same with this cone. We have the circle, but then it's also got height with it. And a pyramid has a square on the bottom, in this case a square pyramid, and it also has height. And then we have this sphere, which looks kind of like a circle in a drawing, except to denote a sphere in a drawing on two dimensions, you kind of use some shading to show that it has depth in it, whereas with a circle we just show a circle around the outside. The flat surfaces of all these three-dimensional figures are called faces. So you see this cube here has 6 faces. It's kind of like a die. So you got one up top, one on the bottom, one on the side, one on the other side, and one on the front, one on the back. So 6 faces here. Now this rectangular prism also has 6 faces, similar to that. They're just not all the same. You have 2 faces on this cylinder, 2 circles. You got another face on the bottom of this cone. This square pyramid has 5 faces. It's got a square on the bottom and then 4 triangles, one of which you can't see right now because it's on the back side. And a sphere has no faces. Three-dimensional figures also have edges. Edges are line segments that connect 2 faces. So for instance, this edge here connects the front face and the side face. This edge here connects the front and the side, or this edge here connects the front to the bottom. A vertex is a point where 2 or more edges meet. So here, this is the vertex of that edge and also this edge. Here's a vertex showing where several edges meet. This vertex has a few different edges touching it there. Now a prism is a three-dimensional figure with 2 parallel and congruent faces that are polygons. So for instance, this cube here could also be called a square prism because it has a base, which could be the bottom. So this bottom square is congruent and parallel with this top square. So either of those could be bases. The side could also be considered a base because it is congruent and parallel to this side over here. And the front could be a base, and the back could also be a congruent and parallel face, right? With this rectangular prism, it's got any of these can be bases as well. You could have this square base on the side because this side is parallel and congruent. You could have this top rectangle because it's parallel and congruent to the bottom rectangle. Now with this cylinder, there's only 2 things that can be faces or bases. You have this circle up top is congruent and parallel to this circle on the bottom, so those are either one of those could be a base. So that's with prisms. Now prisms can be called anything based on what their base looks like. So for instance, if I want to make a triangular prism, I would just draw 2 triangles, assuming these are congruent and parallel. We can make some lines that connect their vertices. It's not going to be perfect, but you get the idea. So well, that's pretty bad. Let's try that again. So when I'm drawing three-dimensional figures, I try to offset them a little bit so that you can show the connecting edges. That's again not perfect. It would be more perfect if I made the bases congruent. But so if these triangles are congruent and parallel, then they would be the base of this prism, and so you would call it a triangular prism. Notice, although these 2 rectangles may be congruent, since they're not parallel, you cannot consider them a base. You could also have a pentagonal prism. Right, so if I made something like this, kind of like a house, you would just draw another offset one, and then if you connected them, then the bases would be considered pentagons, and it would be a pentagonal prism. Oftentimes you'll see dotted lines in three-dimensional figures. That shows edges that are invisible because the shape would kind of be in the way of you seeing that edge. So there'd be several of these lines would be invisible, and so you could make them dotted. So you can call a prism anything. Like there's an infinite amount of prisms. It's just whatever the base looks like. So you could have, I showed triangular. This is pentagonal prism. You can make a hexagonal prism. You know, whatever shape is the base is the name of the prism. Now a pyramid is a three-dimensional figure with one polygon for a base. So you've probably seen or heard of Egyptian or Mayan pyramids. Here we have a square pyramid. Now the bottom of this pyramid is a square, obviously. That's why I call it a square pyramid. There's an invisible line back here that you wouldn't be able to see. All of the other faces of pyramids are triangles. So you see there's one here, there's one on the side, and there'd be one in the back that you can't see. And the faces all meet at a vertex. And again, you name a pyramid by its base. So you can have a triangular pyramid, which would have 3 sides. You could have a square pyramid like this one, which would have 4 triangle sides. You could have a pentagonal pyramid, which would have 5 triangle sides, and so on. So there's an infinite amount of different pyramids you could have. And there are some three-dimensional figures that do not have polygons for bases. For instance, this circle here, a circle is not a polygon. That's why instead of calling this a circular prism, we have a special name for it called a cylinder. Same thing for this. Instead of calling this a circular pyramid, we would call this a cone. And then a sphere obviously has no bases as well. And that's it for this video. Thanks for watching.